Hello, and thank you for joining us today on our ARDEX Introduction to Polished Concrete and Polishable Overlays webinar. Today's webinar is going to talk about the history of polished concrete, what exactly it is, the advantages of polished concrete, some of the applications we see it in, the challenges that are associated with polished concrete, and some of the solutions that we can incorporate. Then we'll go on to discuss about the equipment, tooling, and processes of polished concrete, and finally we'll talk about the market and business opportunities available. So let's talk briefly about the history of polished concrete. Polished concrete is actually a relatively new entry into the flooring surface world. Prior to 1998, polished concrete was associated with terrazzo. We all know terrazzo as being a glass marble or granite chips, typically bound up in a cementitious or epoxy binder, and then that surface is prepared using carborundum stones and water. That is radically different than what actual polished concrete is. The true first polished concrete surface occurred quite by accident. It was during a Tunisian palace renovation back in 1998, where the construction crews were forced to prepare the concrete slab without the use of water. During the grinding process, they noted that the slab was taking on a very beautiful sheen with a very nice aggregate exposure. Following it to its logical conclusion, they ended up with a very beautiful polished concrete slab. Shortly thereafter, in 1999, the first planned installation of a polished concrete slab was undertaken at the Bellagio Hotel in Las Vegas, where a 40,000 square foot warehouse space was polished. And from 1999 to today, U.S. tool and equipment manufacturers, as well as chemical manufacturers, have refined the process and continually improved it. So what exactly is polished concrete? Well, according to the International Polished Concrete Institute, polished concrete is defined as a process which enhances the natural character of the concrete through a series of steps to create a more dense wear surface with greater durability. There are two primary methods to create this sheen: topical or mechanical. Well, within the industry today, these primary methods, the topical and mechanical, are better known as a grind and seal or a full polish. Whether it's a grind and seal application or a full polish, there's an organization out there called the Concrete Polishing Council, and they are a sub-council of the American Society of Concrete Contractors, and they have defined three different classes of aggregate exposure. Aggregate exposure and the sheen of the concrete are the two biggest considerations when dealing with a polished concrete floor. So with the aggregate exposure chart that we see here, you'll see that the CPC has defined a Class A aggregate exposure as revealing 85 to 95% of the cement fines. So basically, all you're going to see in a Class A installation is the cement fines. With a Class B, you're going to see the cement fines as well as the larger or the medium-sized aggregate, and with a Class C, you're going to see the heavier, deeper aggregate. Now, obviously, as you go down in classes here from an A to a C, it's going to require a heavier grind to expose the deeper, more larger aggregate. The important thing to remember here is that if a specifier or an architect or designer specifies a Class A aggregate reveal, which is largely just the cement fines, and the installer inadvertently cuts through to reveal the larger aggregate, there's really no going back at that point. You cannot repair an installation where you reveal the deeper aggregates and the finer aggregates were specified for the installation. So it's important to take note of that and be aware of that. And this is a chart that is commonly referred to within the design community. The other one is the finished, the concrete appearance chart. This specifies levels of sheen, basically, anywhere from a flat or a ground surface sheen to a highly polished surface shine. These are not subjective numbers. These are actually quantitative. They can be measured through the image clarity meter, and the process is defined through ASTM D5767. DOI, which is the distinctiveness of the image, is a very important concept to understand when it comes to clarity and shine or reflection of the finished surface. Again, this is something that will be specified by the end user, by the designer or the architect. So if somebody is looking for a highly polished surface, you are going to get a highly reflective surface on the clarity meter. So it's important, again, to understand that this is not a subjective number, but a very quantitative number, and can be the difference between a floor being accepted or rejected. So going back to the full polish or grind and seal method, there's some very distinct differences between the two. We'll start here with the full polish. And the full polish is basically a process of cutting and refining and chemically treating the concrete surface. It consists of 3 stages. We're going to grind, hone, and polish. And what the full polish method does, it's a process which enhances the hardness of the existing concrete to create the sheen or finish level that ranges from a low to a very high gloss level. The important thing to note here is that the shine or the sheen is achieved through the mechanical refinement, the chemical and mechanical refinement of the surface of the concrete. Now, this is in stark contrast to the grind and seal method. The grind and seal method and the full polish actually do share some initial characteristics or initial processing methodologies. We are going to cut, refine, and chemically treat a concrete surface that is going to receive a grind and seal. It also consists of the grind, hone, and polish phases. However, unlike a full polish, with a grind and seal, the surface refinement is going to stop at a much lower polish level. So you're not going to get the shine through a mechanical or chemical refinement. The shine comes through the application of a film-forming sealer or wax. The surface gloss is a function, therefore, of the sealer or the wax. It's not a function of the refinement, the mechanical refinement of the surface. The disadvantage of this to a lot of people is that the concrete often will have a coated or sealed appearance. You will not have the same level of clarity or reflective clarity that you will have with a full polished system. So regardless if you're going to use a full polish or a grind and seal, there are 2 methods to achieve aggregate reveal and to start processing up the concrete. These are the wet method and the dry method. Contractors can choose between either one of the 2, and most contractors will have the ability to do both. Wet processing is oftentimes preferred because it extends the life of the diamonds. The diamond tooling is one of the most expensive parts of the polished concrete process. However, one of the issues with polishing wet is that it will create a slurry. You can imagine if you're applying water to a process which is grinding the concrete and creating dust that's going to mix with the water to create a slurry, and that requires to be disposed in an environmentally friendly way. This is material that cannot simply be placed on a sewer drain or any type of public drain. It has to be dried out and turned into bulk material, whereupon it can be disposed into a dumpster. Dry processing, therefore, is much faster because it's eliminating the whole water component, so you don't have the issues associated with dealing with the slurry. However, you do require dust containment systems that are fairly robust, particularly with the OSHA regulations that we've come up against in the last few years to protect the health of the installers and workers. But one of the negative or downsides of the dry processing system also is that the tooling, as a result of the friction created by grinding, will wear quicker than it will wear with a wet polishing system. So which is better, full polish or grind and seal? Well, both do have their advantages, but traditionally full polishing is often seen as the preferred method. There's several reasons why. Number one, the extended longevity of the product. You're creating a higher refined surface than with a grind and seal. Typically, you're taking up to a 3,000 or 3,500 grit, and we'll get into the grits later. But the point to note here is that you're more refining the surface to create a higher abrasion resistant surface. It's a higher refinement, it's a more dense surface, therefore it's higher abrasion resistance. The aesthetics are another very big consideration. There's no filmy appearance. With a full polish system, you get a very clear image, you get a very clear reflectivity. The DOI that we referred to earlier, the distinctive image, is much more clear than you get with a film forming sealer that's applied during a grind and seal. And sustainability is a big issue. Polishing, a full polish provides a finish that doesn't require the harvest, manufacture, or transport of additional materials. You're not putting any type of resilient floor covering on top of it. And as opposed to a grind and seal, there's no need to put on a film forming sealer that may be urethane or epoxy based. And you also have lower maintenance. And you can see I have a little asterisk here because I have to emphasize this point that lower maintenance doesn't mean no maintenance. And there are some considerations with a full polish system that use a penetrating guard product that we have to understand going forward. And we'll get into that a little bit later as well. So what are some of the advantages of polished concrete? Well, we started to allude to them in the previous slide, and one of them obviously is the extended longevity. With the highly refined surface, you're getting a 21% more impact resistance when you measure it according to ASTM C805. and you get about 400% more abrasion resistance than the concrete if it is left unprocessed or unrefined. As a result of the impact and abrasion resistance, you're not as susceptible to damage from rain, mud, or other elements that are associated with inclement weather. So in addition to extended longevity, the life cycle is much longer. Fully refined, full polished system creates a very dense surface. It's more spill and stain resistant. It's stain resistant, and you notice here it's not stain proof. And again, we'll talk about that in a little bit. But as a result of the higher refinement, you're going to get a longer lifespan. You typically are going to average about 60% lower life cycle costs when compared to other floor surfaces such as coatings, resilient floor coverings, tile, stone, or even terrazzo. Beauty is obviously one of the biggest considerations. It's a very aesthetically pleasing floor. It's very unique in the aesthetic that it presents. And again, the clarity of reflection with a full polish concrete surface cannot be matched. Light reflectivity is something big that not a lot of people think about. If you have high light reflectivity, you're going to have greater visibility, and that will equal the lower artificial light requirements in general. So you have a lower need for artificial lighting and therefore lower utility costs. And it's also breathable. Slab moisture will readily pass through a full polished concrete slab. So full polish is on a moisture sensitive floor covering or moisture sensitive floor product. So some of the challenges we've all seen in recent years with moisture sensitive floor coverings aren't in play here with a full polished concrete slab. Additional advantages are obviously the sustainable and leak credits you can achieve through the specification of a full polished concrete slab. It's environmentally friendly. You're not using any type of acrylics or epoxies or urethane sealers over the surface. As a result, there's really nothing to dispose of as you're remodeling. Using a structural slab as your finished floor surface will help to contribute leak credits in things such as materials and resources, energy in the atmosphere, and low emitting materials. So it's a very sustainable floor. And one of the biggest advantages that the polished concrete industry has touted for years is a lower maintenance aspect of it. Resist stains from oil, time works, and scuffs. You'll know I have resist here in italics. Again, we have to emphasize the point that it resists. It's not stain proof. So we'll get into that further when we talk about maintenance. There's really no specialized equipment needed for normal maintenance. The typical cleaning methodologies you're using on existing floor coverings in a building, whether they be resilient or stone or terrazzo or ceramic tile, you'll be able to use on polished concrete. No special chemicals are needed. You can damp mop the polished concrete. However, auto scrubbers are recommended just as good maintenance protocols. As a result of all these, you have a much lower maintenance cost overall. So what are some of the applications we see polished concrete going in? Virtually anywhere. You can see this list includes just about any application you can think of. I like to say anywhere where traditional floor coverings can be installed over concrete, polished concrete can serve as an alternative. So anything from a restaurant to an office to a public building to schools, hospitals, polished concrete is definitely a consideration. Some of the applications we've seen it in, again, showrooms and restaurants. These are all projects that ARDEX has been privileged to be on. These are polished concrete as well as some polishable overlay applications. But see, like I said, showrooms and restaurants, grocery stores and retail, schools, manufacturing, offices, aviation hangars, and big box stores. And big box stores you left here for last because big box stores are really the industry that really introduced polished concrete into the public consciousness. Once we started to see polished concrete make its way into places like Lowe's and Home Depot, people started to pick up on the natural beauty of it. The retail outlets started to notice the lower maintenance costs associated with it, and that's really where it started to take off. And we're starting to see it go into more traditional retail outlets like the Targets of the world, and big box retailers, like not just big box retailers, but special retailers like Targets. So, having considered all that, it has to be assumed that polished concrete, or it's logically assumed that polished concrete is the perfect flooring solution. I mean, given all the criteria we just listed. Unfortunately, that's not the case. There are some challenges associated with polished concrete, and some of those challenges are as follows. So, from the owner's perspective, some of the challenges are the colors are inconsistent, or not what they're expecting. With an existing slab, you're limited to what you have as far as the paste is concerned and what color that's going to present. The uniformity of aggregate reveal is a big consideration. You can get spottiness with an existing slab, high and low aggregate reveal. Substrate issues such as patches and trenching and ghosting are very apparent with the installation, and the end user or the owner wasn't expecting to see those. The floor may not be as shiny as they wanted. Again, it all comes down to the quality of the concrete that's being processed. And the end user or the owner is often misinformed about maintenance. Again, this goes back to the idea that polished concrete has been positioned as a very low maintenance product. And while it is not a no maintenance product. And we have to emphasize to all parties that maintenance is still a critical part of the polished concrete decision. From an architect or contractor perspective, there's additional challenges. One of the big things from an architect and contractor's perspective is that there's a lack of control over the final aesthetic. You have to deal with the concrete as it is. I mean, you are presented with the slab and it is what it is. So there's really no guarantee of how that's going to turn out. There's also a lack of step-by-step procedures. Given variances in concrete from slab to slab, we really cannot guarantee any type of reproducible procedures. So what works on one slab may not work on another. So the architect and contractor, when they're presented with those facts, oftentimes aren't too keen on accepting it because they like to have a better idea of how they're going to achieve the final result based on well-defined processes. From the installer's perspective, it's similar to what we saw with the contractor and the architect. Is that every slab is unique. Really don't have any control over the slab. So you may have mixed design variables within an existing slab or within an existing installation space. There could be surface imperfections such as cracks, existing patches, trench infill. Ghosting of previous floor covering is a big issue. Floor flatness and slab curl are also big issues. And we're going to go into those in these next few slides to show you what we mean. So for instance, on the slide here on the left, we can see that's an area where the existing slab was trenched out, probably to run some additional utilities and backfilled in or infilled with a Saccrete type of product or some type of bag mortar product. And given that it's not the existing concrete, it's not going to match in terms of color or paste. The color of the paste or the aggregate. The photo on the right is another area that had been patched, not so much a trench area, but there may have been some damage in the slab in that area and was patched with another patching material. Maybe some third-party aggregates were introduced, but again, it's not going to match in terms of the color. The important thing to note here is that these types of considerations won't be polished out. You cannot blend those backfill or patching materials into the existing slab to create a monolithic appearance. So the end user, the architect, designer, the contractor must understand that that's not going to change with the polishing process, and in fact may become more pronounced. This picture here, you can see the little dots there. They actually look like spalls in the concrete that were patched. Perhaps there was a wall there previously that was taken down, and that may have been some texture from some carpet that had been stretched in. And the spalls that were created when this texture was removed were patched with a feather finish type of product. And that cement binder is going to look different than the surrounding concrete. Again, that's not going to be polished on, so those spalls will always appear within the installation. Cracks within the existing concrete. Here you can see some linear crack tone here. These may be some saw cuts that were installed. Maybe it had been some shrinkage cracks associated with the original installation. While they were repaired appropriately and the area polished, you can see they will pop. They will be more pronounced. So if you have an existing crack in the concrete that's been repaired, then you have every expectation, the end user should have every expectation that they will appear in the final aesthetic. Slab curl and differing aggregate reveals. You can see here where we have an isolation joint there in the slab, different slabs poured probably at different times. And the point is that we have cold joints there, so we had the opportunity for the slab to curl slightly. And you can see as you cut it, you get a much deeper, heavier reveal of the aggregate at the perimeter, where the slab may be slightly curled up because you're removing more material than in the field of the installation. So what you get is a heavy, coarse aggregate reveal versus within the body of the slab, where it's the more fine in medium aggregates. This is also another shot of where you can have the cement paste within an existing pour. You can see in the far end of the picture, you have a very light paste, and it blends into a darker paste. This could be the result of how the slab was finished at the time of placement. The point is that your end user has to expect that they may get color variations within polishing the existing slab, even within the same pour. This last slide shows us what happens when modular floor covering is removed and the concrete is polished up. You can see here the grid pattern of where the VCT had been removed is very clearly defined. This is something you have to understand cannot be polished out. The important thing that this slide shows is that where the VCT has been removed and not polished, and you can still see the adhesive residue, you really don't see the image of the grid pattern. This really won't become that pronounced until you actually start to polish it up. This grid pattern, again, cannot be removed despite the amount of grinding you would do on it or processing you would do on it. So you have to be able to present to your end user or designer that this is something that they need to understand is going to be part of the final aesthetic. Now, a lot of end users, a lot of designers, a lot of contractors will be absolutely fine with what we see here and what we saw in the previous photos as well. The images of the patchwork or the trench work or the cracks, the spalls, in this case here with the modular floor covering grid pattern, they're fine with that look. They think it creates an industrial chic or an urban chic look, and they're happy with that aesthetic that's created. However, a lot of end users want a little bit more predictability. They want to know they're going to have a more even aggregate reveal. They want to cover up some of the cracks of the existing concrete. They don't want to see these types of grid patterns. So if your end user or designer desires that outcome, then we had to look at some different alternatives. So what are some of those alternatives? What are the solutions to some of the challenges we saw in the previous slides? Well, the big one is the polishable overlay. And the polishable overlay presents some very big advantages over polishing the existing slab in terms of achieving a predictable result. And the way we do that is by controlling not only the product control, but also the process control. And when we control those two components, we have predictable results. So what do we mean by product control? Well, the substrate prep products and polishable overlays that will be installed are factory controlled, they're quality controlled. We know how they're going to mix and install. We know what's going to achieve a predictable result with the material that's being poured. In conjunction with that, we know how to process it. The polishable overlays have been dialed into the point where we can understand the processes, the type of equipment that needs to be used, the type of tooling, and the type of chemicals that will work on these materials. So there's really no variability. We've been able to identify whether it's HTC equipment or Diamatic or SACE or whoever, the specific equipment and tooling that can be used to process successfully the overlays. Along with that, you get the installation contractor and nationwide distribution networks. Whether it's ARDEX or a competitor, there's contractors that have been trained with us. We have distribution networks, obviously, that are able to provide the proper, not only the priming products, but also the polishable overlay products themselves. And again, when installed in accordance with their written recommendations, we have a predictable result. And finally, we also have job site support. We have a technical department that allows us to be on site to do job starts to help the installer and the architect and designer understand what the overall installation is going to look like. We can give them a reasonable expectation of what the overall installation is going to look like. Another consideration with the polishable overlays is you're able to not only topically dye and stain, which you can do with the existing concrete slab, but more importantly, you can actually include integral dyes with the polishable overlays. This gives you a lot more design options, and it gives you a lot more robust and vibrant color palette to work with as well. While topical dyes and stains are great, they typically are reactive and can only color or stain the concrete up to a depth of maybe a 1/16 or an 1/8 of an inch. Whereas an integral dye, you'll have that dyed all the way through the product. So if something were to fall or chip the concrete or chip the overlay, you're going to have that color that's through the material, so it won't be nearly as obvious. So if we're going to go with the polishable overlays, if that's something we want to consider, what's the process for incorporating them into our project? Well, it comes down to what we're all familiar with when it comes to our underlayments. The first thing is we have to have proper prep. And what we mean by proper prep, we've all read this in innumerable ARDEX letters and technical data sheets. All concrete must be sound, solid, and clean. That's the golden rule. We might want to make sure there's no bond breakers on the surface, no oil, grease, dirt, curing compounds, anything that's going to interfere with the bond of the ARDEX priming system to the concrete. Typically, we're going to require a iCry surface profile of 3, and this is because we're going to be using a 2-part 100% solids epoxy priming system. Whether that's in the case of ARDEX, whether that's the EP2000, the MC Rapid, any manufacturer of a polishable overlay is going to recommend highly or actually require the use of an epoxy sand broadcasted priming system. So with polishable overlays, is moisture consideration? Not so much with a full polishable overlay, but if you're going to do a grind and seal, moisture is absolutely a consideration, and we can detail that later. But it's just a good idea in general to have an understanding of what the moisture content of your slab is. So we're going to want to test in accordance with ASTM 2170. We're not going to want to exceed the manufacturer's recommendation for their overlay material, particularly if it's a grind and seal. But if it does exceed the moisture recommendations or the moisture specification limits of the manufacturer, then we're going to want to use a moisture control system. In the case of ARDEX, you can use the ARDEX MC Rapid. And the nice thing about that application is that the ARDEX MC Rapid can also be used not only as the moisture control system, but also as the priming system as well. So it's not like there's an additional step if there's high moisture in the concrete. We can use the MC Rapid as a priming system as well as the moisture control system. As with underlayments, we want to make sure we treat joints and cracks appropriately. We have to honor all existing joints and cracks that are moving. That does not change. Whether it's a resilient floor covering, stone, porcelain, terrazzo, polished concrete, you have to honor all moving joints up through the installation. These include expansion, cold joints, or isolation joints. However, all non-moving joints, anything that's dormant, including a saw cut that's been activated, we can actually repair them with something like the ARDEX Artifix product and go over top of them. The important thing to note here is it's got to be dormant and it has to be repaired. We're not talking about patching or filling a crack. We're actually talking about repairing a crack, and that's where the ARDEX Artifix product comes into play. Once we've done our proper prep and we've treated our joints, we're going to prime with our 2-component 100% solids epoxy. Again, whether it's the EP2000 or the MC Rapid, we want to make sure we have this very rigid base underneath our overlay. We need this for a couple reasons. Number one, it's going to help to reduce the amount of hairline cracking and potentially telegraph in from the slab below. But also, the grinding equipment that we're putting over top of these polishable overlays is extremely heavy. And so when you put something that heavy over a micro topping or a topping that's installed in typically no more than 3, so half an inch, we want to make sure that we give it the best chance of success by making sure it has a very rigid base. The application of the primer also, the 2-component 100% solid sand broadcasted epoxy, also is used to fill any type of micro cracks in the surface of the concrete. We can't possibly, if we've got spider cracking throughout the surface of a slab, we can't go in and chase out all of those, obviously, but we could use the epoxy priming system to fill in those very fine cracks. So once we have our prep and we've addressed our cracks and installed our priming system or our moisture control system, we're going to install our overlay. And these are some of the tools we're going to use with our overlay systems. And you can see all these tools that we see here are the same tools we use with our underlayment products. Everything from the gauge rake to the smoother to the cleats, the drill. We're really not talking about doing anything out of the box in terms of placing the material. It's going to be very similar to what we've been doing for years with our underlayment products. One of the questions we get often is the spike roller. Should we use a spike roller to spike roll or not? That's the question. The spike roller presents a couple challenges. The biggest challenge is, number one, it leaves a very distinctive pin dot pattern in the surface. When you the spike roller is used, it's typically used in place of the smoother to break the surface tension of the material, to allow the material to sit flat and smooth. And when you do that, it leaves a pin dot cushion type of look in the surface. That will not be able to be ground out. So if your end user is okay with that look, then by all means use a spike roller. But if they're not, don't proceed under the assumption that you can spike roll it and we'll just grind out that pattern. You're not going to be able to do that. The other problem with the spike roller, the other consideration with the spike roller, is that when you use it with our heavy aggregate materials such as the 521 or the 523 or any material that has a heavier aggregate in it, the spikes can tend to push the aggregate deeper into the mix, which makes it harder to get down to that material, get down to that aggregate when you start to grind. So it's a little bit more difficult to get a good aggregate or good even aggregate uniform reveal. So those are two of the considerations you want to look at when evaluating the use of the spike roller. Personally, I don't like the use of it. If you're going to use it on a polishable overlay, we recommend that you follow it up with a smoother over the surface to try and eliminate some of that patterning. So with the installation, a couple good rules or good conventional work practices to follow. As with underlayments, you want to strictly honor the powder to water ratio. If anything, you want to be more strict when you're doing an overlay material. You got to remember, this is the finished surface, so you're not putting something over top of this. So you want to make sure you get this part right. I tell folks all the time, the most important part of a polishable overlay isn't the processing, it's the placement. If you screw up the placement of the polishable overlay, there's no way to salvage it with the grinding process. So it's very important to make sure you honor the powder to water ratio. It's also important that you pour the material in rapid succession to make sure that you get good blending from batch to batch. We want to be able to blend each individual pour by intermingling them. So as we're running down a wall and we go back to the starting point to do our second row, we want to make sure we push new material into old material to blend them together. If you don't, after processing the material, you can get what's called ribboning, where you can see each line of pour. So you want to make sure that you actually push material into the existing material and pull it back out to make sure you marry those two pours together. This obviously implies you have adequate manpower. I will stress highly, this is not, a polishable overlay is not something you can buy with a skeleton crew. You have to have adequate manpower. You have to do the pre-planning, pre-job planning. You have to make sure everybody understands their roles and responsibilities and that they stand by those roles and responsibilities and not switching it. So if somebody's measuring water, that's all they're doing. If somebody's cracking bags, that's all they're doing. If somebody's running the material out to the installation area, that's all they're doing. If somebody's mixing, that's all they're doing. You have to have adequate manpower. Again, if you screw up the overlay portion, if you screw up the installation portion, you're not going to be able to salvage it with the processing. So adequate manpower is critical to the success of the polishable overlays. And after you get the material down, you want to make sure you allow the material to cure in accordance with the manufacturer's recommendations. Typically, that's about 16 to 24 hours before you're going to start processing it. So once we do begin processing, what are we talking about in terms of equipment and tooling? Well, as a real quick refresher, you're going to remember, we're going to do a grind, hone, and polish on these materials, just like we would on a polished concrete. It's just as we would on the concrete if we were polishing that. So what are we going to be talking about here in terms of equipment? We're looking at planetary grinders. If we're doing a dry polish system, and I will tell you right now, at this point, ARDEX products are dry polish only. You want to make sure that you have a adequate vacuum and dust collection equipment. Most manufacturers of planetary grinder have a grinder dust collection system that meets and exceeds OSHA recommendations. You also want to make sure you have an edge grinder and high-speed burnisher. A lot of times installers will forget these two components, and this is actually where most jobs go south. If you're not able to blend appropriately the edges with the field, then you're going to have a problem with picture framing, and that's something that most end users won't accept. So you want to make sure you have the proper edge grinding equipment. Edge grinding should be performed prior to the grinding of the field. It's something that should not be minimized and should be figured into your jobs when you're bidding it, because edge grinding is probably the bigger portion of your labor costs when it comes to processing the installation. And a high-speed burnisher. propane high-speed burnisher. The benefits of a propane high-speed burnisher come into effect, particularly with a full polish system where you have to burnish in the guard products at the end. You need the speed of a high-speed burnisher, over 2,000 RPM, but you also need the head weight. There's a lot of burnishers out there that build themselves as a high-speed burnisher, but they don't have any head weight. They operate off of a standard 110 outlet, but they're not giving you the horsepower or the weight to heat up that guard product to melt it into the surface of the polishable overlay of the concrete. So if you're going to be in this and you want to succeed at it, an investment in a propane high-speed burnisher is paramount. As far as the equipment is concerned, the first cut, the grinder is one of the most important, obviously, parts of it. A rotary grinder is absolutely fine to be used over polished concrete or polishable overlays. However, the way rotary grinders operate, you have to make sure you move those rotary grinders left to right as you're moving down your grinding path in order to create an even scratch pattern. To eliminate that, we recommend the use of a planetary grinder. A planetary grinder incorporates the use of a large primary disc and then 3 or 4 satellite discs that are mounted on the primary disc. The satellite discs move counter-clockwise or in counter rotation to the way that the primary disc is moving. The benefit of this is that you are able to create a nice even scratch pattern without creating any type of linear tracking. So planetary grinders are typically recommended if you're going to be doing a considerable amount of grinding. However, rotary grinders can be used. You just have to be aware that you have to do a little bit more attention to detail as far as moving the grinder left and right. When we talk about tooling, we're actually talking about the diamonds that do the actual cutting, honing, and polishing of the concrete or the polishable overlay. We'll get into each of these individually in a few minutes. The important thing to note here is that the diamonds that we're talking about are bound up in a matrix. When we're talking about cutting, we're talking about a metal bonded diamond. In other words, we have diamonds that are bound up in a metal matrix. We're talking about honing, we're talking about diamonds that are bound up in either a ceramic or copper type of matrix. And then with polishing, we're talking about diamonds that are bound up in a resin bond. As we alluded to in the last slide, diamonds are what do the actual cutting, honing, and polishing of the concrete or polishable overlay. And those diamonds come in a variety of different sizes based on what their function is in the process. So for instance, with a 30 or 35, we're looking at an average diamond size that's significantly larger than the grit size of a diamond in a 3000 pad. The important takeaway here is to note that the lower the number, the bigger the diamond. It's similar to sandpaper when we're sanding wood. It's the same concept. We're going to do our bulk removal with the lower grit sizes, and we're going to refine up through the higher grit sizes to get the refined surface. So now that we have an understanding of what the equipment and tooling is, what are we talking about when we're talking about processing the concrete or the polishable overlay? Processing of the concrete or polishable overlay begins with the grinding phase. And the grinding phase incorporates the metal bonded diamonds that we referenced earlier. These are the diamonds that have a much larger grit size. The metal bonders are used for the first cut, potentially the first several cuts, depending on how hard the concrete is. Typically, they'll range anywhere from a grit size of 30 up to 200. And these diamonds are used for the bulk removal of material. This is where you're going to get your aggregate exposure. These will remove the heaviest amount of material, and by doing so, it also creates a scratch pattern on the surface of the concrete that will be removed by the successive stages that include honing and polishing. So after we remove our bulk material, we're going to have to now remove the scratch pattern that was left by the heavier grit diamonds in the metal bond. So now we move into the honing phase. And the honing phase incorporates the use of ceramic bond diamonds. Now these diamonds are typically smaller. They range anywhere from a grit size of 50 up to 200. They are bound up in a ceramic or a copper matrix traditionally. And these tools are used to create finer scratch patterns. So the honing phase will introduce its own scratch pattern into the surface of the polishable overlay or concrete, but it's going to replace the deeper scratches that were left by the metal bonded diamonds. By the time we reach the end of the honing phase with the ceramic or copper bonds, basically all the scratches should be removed at that point. So following the removal of all those fine scratches, we're going to move into the densification stage. And densification is a very important concept to understand whether we're talking about polishing concrete or polishable overlays. Densification is often required simply to create a more dense surface. It creates a more harder surface, so it's more abrasion resistant and therefore more resistant to topical staining, and it adds to stain resistance in general. So what is densification? Well, basically, densification is a chemical reaction between a silicate and calcium hydroxide or free lime, which is in the concrete or polishable overlay. This material, the calcium hydroxide or the free lime, is left over after the Portland cement hydrates. There's excess calcium hydroxide, and typically when they're in the surface of the concrete, it is free to react with the silicate once that silicate's introduced to it. We do this through the use of a potassium, sodium, or lithium silicate. So that is referred to as the carrier, the potassium, sodium, or lithium. That carries the silicate into the surface of the concrete where it reacts with the calcium hydroxide to form a product called calcium silicate hydrate. Now, this material is like a gel that will fill in the capillaries in the soft surface of the concrete, and this is how we make it a more dense surface. So what is the difference between a sodium, potassium, or lithium densifier? Basically, it comes down to a question of molecule size. You'll see on this slide that a sodium molecule is much larger than a lithium molecule. Therefore, when you have a lithium silicate densifier, it's able to carry the silicate deeper into the concrete surface where it's able to react at a deeper level with residual calcium hydroxide. The net benefit is that you have a deeper penetration and therefore deeper densification of the surface. It becomes much more abrasion resistant. For this reason, lithium densifiers have become pretty much the go-to densifier within the industry when it comes to polishing concrete. So after densification occurs, we're going to jump into the polishing phase. And the polishing phase is where we actually start to get the shine to appear on the concrete, polishable concrete or polishable overlay. The grit sizes for the diamonds will range anywhere from a 200 to a 3,000 grit. This is where grind and seals and full polishes start to part company. So for instance, with a grind and seal, we may use a 200 or 400 grit size on the grind and seal application and then stop, at which point we'll put on a film forming sealer. With a full polish, we're going to continue taking it up to 1,500 or 3,000 or even higher. And with each successive step in a full polish, you're continuing to close off the surface and refine that surface of the concrete, which is giving you that full polish look. So the last step in processing your polished concrete or polishable overlay is protection. And protection for a full polish system includes the use of a penetrating guard. The penetrating guard is burnished into the surface. This will enhance the sheen and increase stain and abrasion resistance. This is where the high-speed burnisher comes into play. Penetrating guards have to be heated up to a certain level in order for them to react the appropriate way. As far as a grind and seal application is concerned, again, we're going to stop much earlier in the polish process and apply a film forming sealer. Regardless if it's a full polish or a grind and seal, we want to be able to protect the newly polished overlay from spills and contamination by installing a temporary breathable floor covering. When we do install a temporary breathable floor covering, we want to make sure we go wall to wall. If we do not, we get differential drying of the overlay, and that could lead to discoloration. We also want to avoid moisture for a minimum of 72 hours over the installation. We don't want to permit any standing water, and don't place any plastic, rubber mats, rugs, furniture, or such over the overlay. Again, this will prevent drying evenly. Those types of items will trap moisture and result in a cloudy finish. With regard to maintenance, whether it be a full polish or a grind and seal, we want to make sure we strictly adhere to a maintenance program. And a maintenance program has several aspects to it. There's a daily, periodic, and annual or semi-annual maintenance plan that we need to stick to. On a daily basis, we want to make sure we dry or dust mop to remove any dirt and grit on the surface. Periodic, that can be anything from daily to weekly to monthly or bi-monthly. We want to make sure we hit it with an auto scrubber with a pH neutral cleaner and a white or red pad. We need some agitation to remove dirt that may have been ground in. It's imperative that after an auto scrubber that we do a clean water rinse. Any chemicals left on the surface of the grind and seal full polish can act as a magnet for additional dirt to collect. So we want to make sure that we remove any residual chemicals with a clean water rinse. Buffer micro polish is recommended on a regular basis. Again, that could be anywhere from weekly or bi-monthly to quarterly. But a buffer micro polish helps to bring back the shine to the surface, whether it is a grind and seal or a full polish. And we can adjust our timing based on the type of traffic and the amount of traffic that the floor is going to be exposed to. Annual and biannual maintenance includes the use of reapplication of the topical maintenance. Again, whether it's a grind and seal or a full polish, the guard products or the sealers have to be maintained. This is often done on an annual basis or biannual, again, depending on the type and amount of traffic over the surface. Grind and seals do require more maintenance because they will be maintained similar to how a resilient floor covering is currently maintained. That is maintenance of the sealer and or wax that may be used over the surface. So periodic maintenance of the wax or sealer will occur with more frequency than you would with a traditional full polish. But good maintenance practices, whether it is with a full polish or grind and seal, require that any topical stains be cleaned up as quickly as possible. That's just stain protection 101. So let's talk quickly about market opportunity and how it may fit into your business. Currently, the best estimates out there for the market in the United States show that about 5% of the total commercial hard surface flooring, or just over 80 million square feet, is polished concrete. Polished concrete is expected to grow by 25 to 30% through the end of this year, and we know that it's growing at a much faster rate than traditional hard surface flooring. Retail, to include the do-it-yourself home improvement stores such as Lowe's and Home Depots, they make up about 74% of the polished concrete business. Of the total square footage out there that is polished concrete, 19% requires extensive concrete preparation. What this means for us is that consideration of an overlay is often the only answer. 65% of all polished projects are renovations, and 75% of those are going to incorporate an overlay into some portion of the project. You can do the math yourself, and you can see that there's an extensive opportunity, therefore, for the use of overlays in the polished concrete industry. With regard to new concrete, obviously, given that we have a lot more control over the mix design, polishable overlays are used very rarely when it comes to new concrete. As far as the business opportunity is concerned, market research confirms the market for polished surfaces is continuing to grow. We see polished concrete and polishable overlays making their way into smaller retail, commercial, and office spaces, as well as into the residential market. As a hard surface alternative, it is comparable with tile, and as a flooring alternative, it really is the only unique finished flooring surface out there. For this reason, it appeals to the design community, given that they are given the opportunity to design using tints, aggregates, terrazzo strips, and this leads basically to unlimited design options for them, which is very appealing to the designer. Additional business opportunities, again, whether it's a grind and seal or a full polish, they can provide additional revenue streams through ongoing maintenance. With the grind and seal, by definition, it requires use of a film forming sealer. And as we said earlier, those film forming sealers and acrylic waxes that are installed over top have to be maintained on a fairly regular basis. So reapplication of those sealers can be sold as a maintenance program, an ongoing maintenance program. And even with full polish, where you're using a penetrating guard that has to be burnished, as we said earlier, those penetrating guards have to be rejuvenated on a biannual or annual basis, not only to bring the shine up, but also to add additional protection to the surface. So what about your commitment if you decide to go down this road? Well, polished concrete overlays do require commitment, and what they are is very simple. You have to commit to investing in the tooling equipment, the chemicals, and the talent. And the talent, I mean, is the operators of the grinding equipment, of the polishing equipment. Just because an individual knows how to do substrate prep and create a CSP3, it's a little different skill set to polish a concrete slab or a polishable overlay. So commit to providing that those people, that personnel, your talent with the education they're going to need to process and polish concrete. We encourage you to support industry organizations. The Concrete Polishing Council does unbelievably helpful work in terms of providing detailed direction and guidance on how to polish concrete. We also ask you to commit to using resources provided by manufacturers of polishable overlays. Manufacturers like ARDEX have specifications where we detail installation practices and processes to achieve reproducible results. We said earlier in the webinar about product control plus process control equals predictable results. This is why you want to commit to using the resources provided by manufacturers like ARDEX, and also take advantage of the educational opportunities that are offered by manufacturers, whether those manufacturers are the manufacturers of the overlay themselves like ARDEX or the equipment and tooling manufacturers. Take advantage of those opportunities. Most of these companies offer free training. I'm sure all of you are familiar with ARDEX and the ARDEX Academy and the excellent training that's available through our multiple locations throughout the United States and Canada. We encourage you to look at other manufacturers of equipment as well. We have a list here you can see of some manufacturers we've had the opportunity to work with in the past who offer training at their facilities. And again, it's excellent training. I've been to a lot of these, and I would encourage you, highly encourage you to take advantage of this type of training. One last consideration when it comes to commitment on your part, we want you to commit to providing your customer with a mock-up. One of the most critical aspects of a polishable overlay is managing your customer's expectations. Failure to manage your customer's expectations can lead to potential claims on down the road when the floor that is eventually presented to them doesn't match the hand mock-up that you gave them prior to the installation. Mock-ups are not hand samples. Mock-ups are typically a 9-foot by 10-foot area that is processed using the same equipment and the same talent and the same chemicals that we'll use on the general installation. It is the single most important thing you can do to manage your customer's expectations. ARDEX has experience with creating mock-ups. We have experience with creating temporary mock-ups, which is something that we can detail to you very easily and work with you to create one so that there's really no excuse for not providing your end user with a mock-up. Why are mock-ups important? This slide I'd like to show is our ARDEX K523, and you can see it has a very beautiful aggregate exposure, almost a terrazzo-like look. Unfortunately, this floor was rejected by the end user, and I'll show you why in this next slide, because in several areas, you will see we had some spotty reveal. In the picture to the left, you have very little aggregate reveal. In the picture on the right, you have a little bit more, but again, it's not as uniform as the area surrounding it. For this reason, there were several areas like this throughout the installation. For this reason, the floor was rejected. The installer had presented them with a 2x2 mock-up that showed a very even dispersion of aggregate, almost like a terrazzo-like look, so that when the full mock-up from the full installation went down and these areas appeared, the end user rejected the floor. With a 10x10 or 9x10 mock-up, these types of spotty reveal can be shown and dealt with prior to the general installation to avoid the potential for a floor being rejected and an ensuing claim. So that's it for today's webinar. I want to take this opportunity to thank you for joining us. You'll see on the screen now my contact information as well as my colleague's contact information, Tim Ellison. Both Tim and I are available for any types of questions you may have, trainings you may desire to take, whether at one of the ARDEX Academy locations or at your location. We are free to come to your place and help you place a mock-up so you can understand how to do that. We're available for job starts, and we're also available to take your comments. Any input you'd like to give us on the ARDEX finished surfaces or on polished concrete in general, we look forward to hearing from you. So please reach out to either Tim or myself, and we look forward to hearing from you in the future. Thank you.